Okay, so let's pick up where we left off in class. We were looking at this example, x squared minus 6x minus 16 over x plus 2. And I was showing you one way by just kind of turning it into a multiplication problem and trying to figure out what the missing factor is. And so we did it that way in class, but then remember I said this won't always work. Okay, so we do need another method for when this method isn't going to work for us. So what we do is called long division of polynomials. All right, now we need to take a step back. It's probably been a while since we've actually done a long division problem. We're used to using our calculators now. So the long division of polynomials follows the same process as long division with just regular numbers that you learned. So let's just do a quick example just to get you thinking about the process for just doing regular long division. So I'm just going on a separate sheet of paper here. And let's say I wanted to do the number 374, and let's say I wanted to divide by 5. Okay, so I would figure out how many times 5 goes into 37. Well, first I would check 5 into 3. It does not. So I'm going to go 5 into 37. That would be 7 times, and I would write it above the 7 because that would be the ones place of 37. 7 times 5 is 35. Then I would subtract, and I would bring down the next number, which is a 4. Now I'm going to ask myself, okay, how many times does 5 go into 24? It goes in 4 times evenly. 4 times 5 is 20. And I would subtract, and I would get a 4. Now, before we learned about decimals, we would stop right there. And we would say the answer is 74 remainder 4. Then, after we learned how to do that, we probably learned about fractions and mixed numbers. So this long division problem would be the same as 374 over 5. And if I had to turn that into a mixed number, I would say, okay, how many times does 5 go into 374 evenly? Well, it goes in 74 times evenly, and there are 4 left over, so that would be 74 4/5. So we're going to use the process of long division and the idea of the remainder to do the problems, the long division of polynomial problems. All right, so now that we've kind of done that little review, what we're going to do now is go back to the example. Here we go. X squared minus 6x minus 16 divided by x plus 2. So this means I'm dividing by x plus 2. So x plus 2 is my divisor. And my numerator goes underneath the division sign, underneath the long division sign. So x squared minus 6x minus 16. So I want to see how many times x minus 2 will go into x squared minus 6x minus 16. So I start with the x in the x plus 2. All right, so I'm starting with this. And I say to myself, okay, how many times will x squared go into, how many times will x go into x squared? Now, I left a little space here because basically what I'm asking myself is, what do I have to multiply x by to get me to x squared? Well, I have to multiply x times x. So we say x goes into x squared x times. And notice how I write it on top of the other x term, the 6x. Now, just like long division, I'm going to come back, take my x, and I'm going to multiply it, but I'm going to be multiplying it by both terms of the binomial. So x times x gives me x squared. So I line it up under the x squared term. and x times positive 2 gives me a plus 2x. And then I subtract. Okay, so now I'm doing x squared minus 6x, so I'm not doing anything with the minus 16 just yet. So I'm doing x squared minus 6x minus x squared plus 2x. Now keep in mind, I am minusing that whole entire quantity. So that negative sign is like it's going to be distributed. All right? So this becomes plus a negative x squared and a negative 2x. So now this x squared plus a negative x squared is going to cancel out. And then I have a negative 6x plus negative 2x, which is negative 8x. And then I bring down the minus 16. Okay. Now let's take another look at that real quick. Changing that to the plus and then the minus, that can sometimes be confusing as well. So let me just use this scrap piece of paper real quick and just explain it in a little bit of a different way, and then you can see which way makes more sense to you. All right, so we had x squared minus 6x minus 16. So we said x goes into x squared, x times x is x squared, and then we have plus 2x. And then I said, okay, we have to subtract this. Well, you can think about it purely as subtraction instead of changing this to a plus and changing these to their opposites. X squared minus x squared is 0x squared, so those go away. And then negative 6x minus a positive 2x is still negative 8x. So however you want to look at it, you're going to get a negative 8x here, and then you bring down the minus 16. All right, now we start again. We come back with our x, and I ask myself, okay, how many times will x go into negative 8x? So I'm basically asking myself, what do I multiply x by to give me negative 8x? Well, I have to multiply by negative 8. So minus 8 goes up here, and that lines up right over the other constant. And then I come back and multiply. So negative 8 times x gives me negative 8x, and negative 8 times the plus 2 gives me negative 16. So I'm subtracting this. So remember, this is going to distribute, so this becomes plus a positive 8x and a positive 16. So negative 8x plus 8x is 0, and negative 16 plus 16 is 0. And in this case, that just means there's no remainder, so it goes in evenly. So my answer is just x minus 8, like we got up here. So here's how you're going to check your answer. You take your divisor, which was the x plus 2, multiply it by your quotient, and you check and see if you get your original dividend back, or the original numerator. You check and check and see if you get that back. So let's do FOIL. X squared minus 8x plus 2x minus 16, and then there's your minus 6x in the middle. If I combine these, so I get x squared minus 6x plus 16. So I know it works. All right, let's look at number 2. Same thing here, but notice my numerator is not written in standard form. I want it to be written in standard form. That's the only way I can do a problem like this. So you basically have two options here. If you like the method we did before, where you're just trying to find the missing factor, you definitely can, but remember you have to rewrite your numerator in standard form. So 10x squared would come first, minus 29x minus 21. Okay, and then you would just see what would go in the blanks. So if you think about my first two, the only way to get 10x squared is if I have a 2x right there. 5 times 2 is 10, x times x is x squared. And then I need this to come out to be minus 21, so that has to be a minus 7. And then we would just check the inside and the outside to make sure we get minus 29x. So 5x times 2x, there's my 10x squared. On my outside, I'm going to get minus 35x. On the inside, I get plus 6x. And then my last two, there's the minus 21. And there's my minus 29x in the middle. Okay? But again, if you don't like that method, or if you think that that gets too complicated now that we have 5x and 2x, then the long division method will always work. So our divisor is 5x plus 3. That's what we're dividing by. And I want to write my numerator in standard form. So 10x squared minus 29x minus 21. And now I'm going to start, okay, how many times will 5x go into 10x squared? So I'm basically saying, okay, what do I multiply 5x by to get me 10x squared? Well, it's got to be 2x. Notice it's the same as the 2x right there. And I will line it up above the other x term. So now I come and multiply. So 2x times 5x, that is 10x squared. And 2x times 3, that's plus 6x. And I am subtracting here. So if you want to, you can change the subtraction to plus and then change the sign of everything inside the parentheses, or you can just think of it as subtraction. 10x squared minus 10x squared is 0x squared. Negative 29x minus positive 6x is negative 35x, because you're starting with negative 29 and now you're subtracting a positive 6. So that's like negative 29 minus 6. And then we bring down the next term. So we bring down the minus 21. Okay, now let's ask, okay, how many times does 5x go into negative 35x? So I'm saying, all right, what do I multiply 5x by? Well, I have to multiply that by negative 7. So negative 7 goes above the constant, the negative 21. And I'm going to come back and multiply. Negative 7 times 5x is negative 35x. And negative 7 times positive 3 is negative 21. And I subtract all this. So this becomes plus a positive 35x and a positive 21. Negative 35x plus 35x is 0. Negative 21 plus 21, remainder of 0. So my answer is 2x minus 7. And I already did the check up here. Remember, I showed you both methods, so I know that that's the answer. All right, let's look at this next one. This next one doesn't have a whole lot of stuff in there, right? X cubed minus 1, and then just x minus 1 in the denominator. Well, in the numerator, we talked earlier about having it in standard form. What I need to do in the numerator is account for all the possible exponents of x that I don't see. So I need to fill in some placeholders. Here's what I mean by fill in placeholders. Okay, there's my divisor, x minus 1. Now my numerator is just x cubed minus 1. But I can't just write x cubed minus 1. I need to fill in the places for the x squared and the x to the first power. So this becomes plus 0x squared plus 0x. Then I can put the minus 1. So I need to see my powers go third power, second power, first power, and then down to 0 power. That's the only way that it's going to work. So I need to fill in my placeholders. All right, let's start. How many times does x go into x cubed? Well, it's x squared. because I need to do x times x squared to get me to x cubed. And that's why I had to fill in my placeholder, so I had a column to write it on top of. All right, let's multiply. X squared times x is x cubed. X squared times negative 1 is minus 1x squared. And I am subtracting this whole thing. So this is plus negative x cubed and plus positive 1x squared. Notice the signs change. So that is 0. And then I have 0x squared plus 1x squared is just 1x squared. Now I'm going to bring down the next term, even though it's a 0, still going to bring it down. So now I'm taking this x and I see, okay, how many times will it go into x squared? Well, the answer is positive x plus x, because x times x is x squared. All right, so x times x is x squared. X times negative 1 is minus 1x. And I'm subtracting that. So this becomes plus a negative x squared and a plus 1x. X squared minus x squared is 0. And then I have a positive 0x plus 1x. That's positive 1x. And I bring down the minus 1. And now I have one more round. So I have to ask myself, how many times does x go into 1x? Well, just once. X times 1 is 1x. And then I come back and multiply. So 1 times x is 1x, or just x, and 1 times negative 1 is negative 1. Now I'm subtracting. So I'm going to add a negative 1x, and then that becomes plus 1. So 1x plus negative 1x is 0, and negative 1 plus 1 is also 0. So my answer is x squared plus x plus 1. Now, of course, if you want to check it, you take your proposed answer, multiply it by the divisor, and make sure that it works out. So you would do the distributive property, distribute the x to everything, distribute the negative 1, and verify that you get x cubed minus 1. And then once you do that, you can safely say that is our answer. All right. Let's look at this next one. So we have the same kind of problem, the fill in the blank. It says, can you create a true statement by filling in the blank parentheses with the binomial why or why not? And what do we think this means? So take a few seconds, see if you can figure out what has to go there to create a true statement. All right, well, hopefully you realized that nothing works. Okay, you can put an x there. That'll give you x squared, but you're trying to figure out, okay, plus what? Well, nothing's going to work there, because how am I going to get 5? 3 times what is going to give me 5? Other than using a fraction, it's not going to work. So, and a fraction might not even work. We just don't know yet. But there's no integer that will work there, so that method that I've used before isn't really going to help me. So I need a new method. But let's go back here. What do we think this means? What that means is that it doesn't divide in evenly. What that means is that I'm going to have some kind of remainder. Okay, so let's look at number 1. Let's do the same problem. So x plus 3 is my divisor. And my numerator is x squared minus 7x plus 5. So I'm going to see how many times x goes into x squared. It goes in x times. And then I come back and multiply. That's going to be x squared plus 3x. Okay, I'm going to subtract. So I'm adding negative x squared and then that also makes this negative 3x. So x squared plus negative x squared is 0. Negative 7x plus negative 3x is negative 10x. And then I bring down the plus 5. Let's see how many times x goes into negative 10x. Well, that means x times negative 10 is what I want. So minus 10 goes right there. And I distribute the negative 10. I get negative 10x minus 30. And now I subtract all of that. So this becomes plus positive 10x and plus positive 30. Well, now when I add negative 10x plus 10x, that's 0. But look, 5 plus 30, I get a remainder of 35. I don't have anything else to drop down, so I know I'm done. So this is a remainder. Okay, now, we don't write it, though, just as R35. Okay, let's go back to my sample long division problem that I did right here. Right? We said we could write it as a mixed number. Well, 74 and 4/5, that's the same as 74 plus 4/5. So that's the form that we write our answer. So I'm going to come back here. So my answer is going to be x plus 3. With the remainder, that means plus 35 over, whoops, I'm sorry, my mistake. My answer is not x plus 3, my answer is this, the quotient, x minus 10. My answer is x minus 10 plus the remainder of 35 over the divisor of x plus 3. Now, you probably want to know how to check this. Well, of course, you should. So let's do an example of how I would check this. And so remember, our goal is to get back to x squared minus 7x plus 5. I could do it on a separate sheet. Okay, so to check this, I am going to take the divisor, which was x plus 3. I'm going to multiply it by the quotient, but I'm also going to add my remainder. That's how I check it. So first I do FOIL. So x squared minus 10x plus 3x minus 30, and then I have that plus the remainder of 35. So like terms, x squared minus 7x minus 30 plus 35. And then again, I have some more like terms. And that gets me back to my original x squared minus 7x plus 5. So that's how you check. So I still do the FOIL, but until I add in that remainder, I don't get back to my original numerator. All right, let's look at the last one. Okay, so what I want you to do is I want you to try this one on your own. I'm going to give you the answer. 4x minus 3 minus 3 over 2x plus 3. Okay, so do that one on your own. Now you know the answer, so you can go through the steps and see if you can come up with the same results. Happy practicing!